Good afternoon, ladies and gentlemen. Let me introduce our investigation, Analysis of Methods and Models for Implementing Databases and Web Interfaces, a case study of student management information systems by Leonid Romanyuk, Igor Chihira, Halina Tulaidan, and Olesa Stanyuk. Today, in the digital environment, it is impossible to develop effective information systems without the proper organization of data storage, processing, and access. Databases and web interfaces are crucial to the software functionality that is used in various industries. With the growing demands for security and speed of system deployment, developers are increasingly implementing projects using combined technological solutions that incorporate different tools and architectural approaches. The relevance of the study is driven by the need for practical recommendations for developers, software architects, and system integrators who are searching for optimal approaches to the implementation of information systems, taking into account real-world constraints, standards, market trends, and technological progress. Here you can see the outline of the previous investigation on this issue and some publications from some authors. Thus, the analysis of the literature shows a wide range of model technological solutions for optimizing software development. However, taking into account the above-mentioned scientific publications, the issue related to the development of database and web interface implementation infrastructure remains still insufficiently studied and requires further elaboration. The aim of the research is to review the methods and models for implementing databases and web interfaces on the example of various student management systems. The current paper discusses different implementations of the student management systems. The first implementation is based on the use of a Java backend with a data storage in a MySQL database and the creation of a user interface using Django and Vue.js. In this complex system, each technology performs its assigned role. Java is used to create initial basic services based on business logic. The reliability of Java in handling concurrency and maintaining performance under high loads justifies this choice. MySQL was chosen because of its support of AC transactions and a wide range of features, including stored procedures for using database-level logic, triggers for automatically responding to changes in tables, and complex join operations for building queries to interrelated data in multiple tables. In addition, parameterized Java queries also serve as additional protection against SQL injections. Prioritizing Java over MySQL allows providing access to RESTful endpoints that are used in the functions of registering, deleting, and updating information about students, thus isolating the layer that the client interacts with from internal database information. Django follows a convention over configuration approach, which can help speed up the development process as automatic generation and updating of tables are carried out through migrations. Security layers such as JWT-based authentication are already part of Django. By using the third-party Auth0 service, which requires approval of each request using a public key retrieved from the GSON web key set, the corresponding endpoints remain light to authenticated users. In many cases, it is necessary to implement an alternative enterprise-oriented approach that retains the modular advantages of Java applications but with a more automated configuration process, which makes Spring Boot an effective solution. The usage of Spring Data JPA is associated with the possibility of developing a repository interface that extends the capabilities of a JPA repository by providing a set of standard functions. For example, if you need to create more specialized queries, you can either use JPA query methods using functions such as find by name or create your own queries. Modern deployments need to reconcile data stored on systems with different databases or combine multiple APIs into a uniform interface. In this context, GraphQL emerges as a solution to the trend of increasingly complex interactions between data. This approach focuses on schematic structuring, allowing the client to precisely specify what data they need. Unlike returning entire objects with potentially unnecessary fields, GraphQL queries are able to capture only the attributes requested by the client. The recent emphasis on containerization has also influenced the way these stacks are packaged and deployed. Regardless of whether a system is implemented with Java, Django, or Spring Boot, the application of Docker always ensures that the working environment remains consistent throughout the development, testing, and production process. By specifically defining dependencies and configurations in the Docker file, incompatibilities caused by differences in setting in local working environments are eliminated. This approach is especially relevant when working with services that work with data from external databases, message brokers, or authentication providers. A multi-container environment with services for the main application, databases, and optional tools is introduced. At any time when scaling or upgrading is required, these containers can be reorganized to replicate services, perform rolling upgrades, or maintain continuous operation during deployments. The figure shows a schematic containerization of components. It is equally important to resolve the issue of the need to integrate the infrastructure as code paradigm using Terraform or Ansible to manage server initialization, load balancers, and networks in the cloud environment. Considering the key principles of separation of responsibilities, authentication, and authorization also require due attention. A Java-based backend can verify a JSON web token to confirm that an incoming request has been received from authenticated user and then assign role-based rulers in order to restrict operations. With approach 1, a monolithic architecture using Docker provides a balanced combination of stable performance and rapid development, but managing multiple technology stacks can be difficult. The second approach supports both monolithic and microservices deployments using Docker and IAC to implement capable enterprise-grade features, although the setup process is more complex. In general, a comprehensive analysis of the methods and means of implementing databases and web interfaces in the context of student management systems allows us to identify both the strengths and limitations of each approach depending on the context of application. The combination of Java or Spring Boot with MySQL and modern front-end technologies such as Vue.js ensures high stability and security, while Django simplifies prototyping and speeds up development through process automation. The integration of GraphQL, Docker containerization, and IA implementation contribute to the creation of scalable architecture.